So we're talking about our radian measure today. So radian measure is another way of writing an angle. If my memory serves me correctly, you did talk about radians last year a little bit. What the radian measure is it's the arc length in the unit circle. So we'll draw a little picture. Here's my unit circle. Main thing about the unit circle is that your radius is always a 1. So let's say I have a 30-degree angle. That would be my 30-degree angle in there. When they talk about it in radian measure, what they're talking about is this arc right here that gets cut off from the 30-degree angle. That's the radian measure. So we got practice going from degrees to radian and radians to degrees. So to change from degrees to radians, you got to do your degrees times pi over 180, where pi stays as part of your answer, unless you're told otherwise. So for letter A, the multiplication sign. So for letter A, I would do 300 times pi over 180. So what we want to do is I'm going to deal with just the numbers. 300 over 180. And then I'm going to use my math, enter, to reduce my fraction. So I would get 5/3. So my radian would be 5 pi over 3. Pi stays with that top number. So 170 again, times pi over 180. Let's have you guys reduce that. What does that reduce to? 17 over 18. So it would be 17 pi over 18. And then it still works the same way with your negatives. Times pi over 180. What does that reduce to? Negative 5 pi over 9. Pretty simple. Is it coming back to you, hopefully? So for our radians to degrees, you would do your radian times 180 over pi. So my letter A, I do 11 pi over 6 times 180 over pi. What happens with our pi? Cancels. One's from the top, one's from the bottom, so they cancel each other out. So all we have to figure out is 11 times 180, and then divide it by 6. 330. Because you got one in the top, one in the bottom. No, it's when you do pi divided by pi. Anything divided by itself is 1. Cancels itself out. B, that's the other way we can write our radian measure. You still do the same thing. 2.5 times 180 over pi. And then we use our calculator to help us out. 2.5 times 180 divided by, get your pi symbol in there. You want to actually use your pi button. So let's go to the nearest tenth. What would our degree measure be? 143.2. So C again, 180 over pi. What happens with our pi? They cancel. So 7 times 180 divided by 12. 105. And then our last one again, 1.3 times 180 over pi. We'll go to our nearest tenth again after you type that in. 74.5. Easy peasy lemon squeezy, right? Mm-hmm. All right, so it can be very helpful to you guys if you can learn to convert the special angles mentally, not always having to do it this way. So in order to do that, we got to actually look at my chart, which for some reason fell on the next page. It didn't stay where it was supposed to stay. It went to the top of the second page because it's mean. It's mean. No, I said mean, M-E-A-N. So 180 in radians is just pi. 30 in radians is pi over 6. 45 is pi over 4. 60 is pi over 3. And 90 is pi over 2. So we got to keep that in mind. So what we would do to do this in our head is you kind of have to think to yourself and kind of break the numbers apart. 150 I can break up into 5 times 30. I was using 30 because that was one of my angles that we just put in our chart there. So some people would say that you have 5 30s to get you 150. So 30 we said was pi over 6. And then you would just put the 5 in there because you have 5 of them. So that just converts to 5 pi over 6. So then for 240, we got a couple of different ones we could use. We could break it up as 4 times 60, which we said 60 was what? Pi over 3, and then you just put the 4 in front, so that would be 4 pi over 3. You could have used also 8 and 30, but then you would have had to reduce at the end, but you would have gotten the same answer. 270, 2 and 90, or not 2 and 90, 3 and 90. 90 we said was what over what? 90 was pi over 2. So we just bring the 3 down. So that'd be 3 pi over 2 is your 270. 135, whenever I get one that ends in a 5, I always try my 45 first. So does 45 go into 135? Yeah. I believe it's 3 times. So then our 45 we said was pi over 4. So this would be 3 pi over 4. So again, that's just another way of being able to do it. I find sometimes doing it that way from degrees into radians is a little trickier. But when you're going from radians into degrees, that way I think is a little easier. So like for here, pi over 3 we said is what? 60, and then 60 times 5 would be 300. For our next one, pi over 6 we said was 30. So then 30 times 7 would give us 210. I think it's a little easier going that way from radians to degrees. We got 2 more that fell on our next page. .210. So here we got pi over 4, which would be what? 45. 45 times 5. Not 180. Not 180. 225. If you look at our chart, 180 would just be pi. Yeah. Okay, and then pi over 6. 30, then times 11. Would give us 330. So if that doesn't work for you, you can still do it out the other way. That's perfectly fine, but that's just a way to kind of make it go faster. So now, if we are dealing with a circle where your radius is not 1, remember, if it was 1, it's all within the unit circle. So if your radius is not 1, the arc length, your radius, and the angle measure are all related in a formula. S equals theta times r. Some people write the formula as theta equals S over r. Those are the same thing. They're just written in a different way. So your S is your arc length. Your theta is your angle in radians. And your r is your radius. So you got to be careful with these kinds of problems. What they love to do is they just switch between the units. So you got to remember to pay attention to what units are they talking about. We're going to have some little unit conversions we have to do first, and then we can figure out our answers. So in number 1, we have in a circle a central angle of 4.2 radians intercepts an arc whose length is 6.3 meters. Find the length of the radius in meters. This one, it didn't change us on it. They're both meters. We don't have to convert anything. So let's draw our circle. Oh, that was a pretty good circle. Draw your circle. So thinking back to geometry, what is a central angle? Central angle means it hits the center of your circle. So the central angle is 4.2 radians. It intercepts an arc. So my arc here is 6.3. They told us to find the length of our radius. So we're looking for our r in our formula here. So S equals theta r. 6.3 goes in for your S because that was your arc length. 4.2 goes in for your theta, and then r stays as r. So we just have to do a little division. 6.3 divided by 4.2. Radius equals 1.5 meters. So number 2, we got a ball is rolling in a circular path that has a radius of 12 inches. What distance has the ball rolled when the subtended arc is 3.5 radians? I just love it when they throw vocab words in there for you. So what we know so far is our radius is 12 inches. Now you could sit here and not really know what they mean when it says subtended arc. But it's the fact that they wrote 3.5 radians. That means what is the other thing we know? the angle. Your angle is your radian. So if they ever talk about radians, that's your angle measure. So we're looking for this time our S. So 3.5 times our 12. What do we get? Oh, good, that's what I got. 42 inches. Number 3, we have a wheel whose radius measures 20 inches, is rotated. If a point on the circumference of the wheel moves a distance of 25 feet, the point travels through an angle whose radian measure is question mark. So our radius is 20 inches, but what's our distance outside the circle? It's in feet. We don't want that. We got to change that. So I got to change my feet into inches. So I got to multiply my 25 times 12. So how many inches does it travel? 300. We got to find our theta. We got to find our angle measure. So S equals theta R. 300 goes in for S. 20 goes in for your R. $300. I had to convert my 25 feet into inches. So what do we get for our theta? 15. Really being kind of mean to that calculator right now. So now number 4, we have a pizza is divided into 8 equal pieces. The outer edge of the crust from one piece is 5.5 inches. What is the diameter of the pizza to the nearest inch? So we should draw our pizza first and break it up into 8 equal pieces. Oh, okay. And you would have no friends, right?
That's okay.
Have you ever asked Siri what 0 divided by 0 is?
0. No,
You'll have to ask Siri what 0 divided by 0 is. It's hilarious. Alright, so we are told the edge of the crust of the pizza is 5.5 inches. So my S, my arc length, is 5.5. We are trying to find what? The diameter. So we got to first figure out our radius. And then we just double it, and we would have our diameter. But what's the other thing we would need to know? The angle. Since it's 8 pieces, and there's 360 degrees total in a circle, how many degrees are in each wedge of pizza? 45. But in our formula, we have to use that as radian measure. So what did I tell you 45 was in radian measure? Pi over 4. Now we can use our formula. We're going to put 5.5 in for S. Pi over 4 goes in for our theta. We're looking for our radius. You'll get a decimal that will round to the nearest whole number. What do we get? Yeah, it would be 7.00, so we'll go to 7. Because I divided by pi over 4, so in my calculator, I did 5.5 divided by parentheses pi over 4. And I give you my 7.00, blah, blah, blah. So then what would our diameter be? 14. Radius is 7, our diameter is 14. So number 5, through how many radians does the minute hand of a clock turn in 24 minutes? So here's our clock. Let's say it starts here, 24 minutes approximately would be like over there-ish. I'm estimating. So the full circle of the clock is how many minutes?
60.
60. So let's first figure out 24 out of 60 is what?
It will be 0.4.
0.4. We actually don't use S equals theta R for this one. So in 24 minutes it goes 0.4 out of how many degrees total? 360, but I'm not going to use 360. I'm going to use the radian form of 360, which would be 2 pi. So let's leave the pi in our formula. Just do your 0.4 times your 2. 0.8, which would be 4 pi over 5. Because 0.4 times 2 is 0.8. If you did your math, enter, which I can do that in my head, it's 4 over 5. Yes, it's 2 pi. All right, then these last two parts, these aren't anything really new. It's calculating our exact value again. It's just this time they gave you the radian form. So when they do that, what you have to do is you have to turn it into degrees first and then do exact value like we were doing earlier. Find your reference angle, what quadrant are we in, all that good stuff. So 3 pi over 4, we've got to turn that into our degrees.
That's 45 degrees times 3, right?
That would be 45 degrees times 3. Nice job. Pi over 4 is 45 times 3 would give us 135. So we're looking for the cosine of 135. Now the cool thing about doing it the way that Paul figured it out is he already knows his reference angle would be 45. So 135 falls in which quadrant? Second quadrant. Cosine, is it positive or negative? Negative. So what's the cosine of 45? Look at your chart. Radical 2 over 2. So it's going to be a negative radical 2 over 2. Can't express enough. You've got to memorize those charts. Or the unit circle. Really, you get your pick. Unit circle or those charts. Those are your choices. All right, next one, tangent of 4 pi over 3. Pi over 3 is 60 times 4 is 240. Again, we already know our reference angle would be the 60. 240 falls in which quadrant? Thirds, tangent positive or negative? Positive. So then what is our tangent of 60? Radical 3. So our next one, pi over 6 is what? 30. So this would be the sine of 30 plus the cosine of 5 times 30, which would be 150. So what is our sine of 30? One half. Cosine of 150. You should know that. Our reference angle is what? Yeah, reference angle is 30. We are in quadrant 2 where cosine is negative. Radical 3 over 2. So they already have the same denominator. We just have to combine them into one fraction. So this ends up being 1 minus radical 3 over 2. So then with our reciprocals, remember, you've got to find the reciprocal and then we got to flip it. So for secant, we got to really find cosine. And then we got to flip the value. So 2 pi over 3, what is that in degrees? $120, yes. So our reference angle is a 60. 120, though, falls in which quadrant? Quadrant 2, which means cosine is negative. So what is the cosine of 60? So this would be negative 1/2. But we want the secant, though, so I just got to flip it. So it would just be negative 2. So for cotangent, we really got to find tangent. This would be 30. Radical 3 over 3. So then I got to flip that, though. So that's 3 over radical 3, which, can I leave that? No. So we got to rationalize it, not radical it. So this gives me 3 radical 3 over 3. And then what happens with these 3's? It cancels. So that becomes radical 3. Your cotangent would be radical 3. No, I did not. All right, and our last one, cosecant. So I got to first find the sine. Pi over 6 is 30, and then times 5. 150. So we are in the second quadrant where sine is positive. Our reference angle was our 30. So what's sine of 30? 1/2. So I've got to first flip that, which becomes 2, but then this also initially was squared, so then I got to square it. So our final answer is 4.